Hello guys, today I want to explain all that mock exam questions. So in the first one, I mean 57, that kind of questions, we said that x plus 1 should be less than 5, but that have to be more than -5. And then we should find the number of integer solutions. So first we should find the values of x, and then we should choose all the integer solutions. So to solve that kind of inequality, we have to subtract negative. We have to subtract 1 from all sides, which will be -6 x and 4. And then we can say the solutions are -6, -5. So all the numbers till 4. So as you see, there are 11 numbers, and the question says find the number of integer solutions. That's why we say there are 11 integer solutions. In 58, 3 elements of A belong to set B. So we have two sets A and B, and from the first sentence we can say that they have intersection point. So 3 elements of A belong to B. Let's say this one is set A and this one B. So 3 is the intersection. So 7 elements of B do not belong to A. So this part, only that part, this is B, but not A. So there are 7 elements. And we know that in total, there are 12 elements. It says the union is 12. And we should find A, but not B, this region. Let's say X, and we know that the sum of all that elements should be 12. So X is 2. X plus 10 is 12. X equals to 2. Next question. Find one interior angle of a regular 15-sided polygon. So maybe we can say that the formula is 180 times n minus 2 divided by n. N is the number of sides. Then you can substitute 15 minus 2 over 15. So that will be, it's better to simplify. So 13 and 15. So let's simplify 180 and 15. That will be 12. So 12 by 13, that will be 156b. But I prefer the other method. It's easier to find exterior angle first because you just divided 360 by the number of sides. That will be 360 divided by 15 equal to 24. And then we know that interior and exterior angles, they are supplementary angles, which means their sum is 180. And then you just subtract 24, that will be 156, which is one of the interior angles. In question 60, for that kind of questions, I said that it's better to find whole numbers. For example, when we multiply the numerator and denominator by 1000, the numerator will be 250 and denominator will be 125. Again, let's multiply by 1000. That will be 125 and 25. And the last one, again, we should multiply by 1000 to get only whole numbers. So 250, 125, it's 2. 125 and 25, it's 5. So 25 over 50, it's 1/2 or 0.5. So 2 plus 5, 7, and it's 0.5. So 7.5 is the correct answer. Okay, in 61, we know the ratio of BD and DC is 3 to 5. Actually, the areas, the ratio of area ABD to the ratio of area ADC is same as the length BD to DC. It's like 3 to 5. If you want, you can prove it by drawing the height of the triangles. So let's say AH is the height of the triangle ABD, and then when we multiply height of that triangle by 3A divided by 2, that will be the area of ABD. And for the other triangle ADC, again, the height of the triangle is H, which is same as the other triangle. So H times 5A divided by 2 is the area of triangle ADC. So we can see that the ratios of the two areas is same as the ratio of sides. We can simplify that H, 2, and A. That will be 3 to 5, as I said. And then let's say 3A plus 5A equal to 64. So 8A is 64, A equal to 8. So area of ABD should be 3 times 8, 24. And area of ADC, the other triangle, that should be 5 times 8, which is 40. So answer is C. We need the area of ADC. If the smaller of two numbers in the ratio 5 to 6, so the ratio is 5 to 6, and the smaller number is 30. So we can just say 5 to 6 equal to 30 to the larger number x. And then we can use cross multiplication, or just we can multiply it by 6. They are equivalent fractions. That will be 36. 6 times 6. Again, maybe you can find cross product by using cross product. That will be 5x and 180. And then you can just divide it by 5, divided by both sides. That will be 36 again. Okay, 63. For what positive value of k does the quadratic equation have two equal roots? Okay, have two equal roots. If it says two distinct roots, that means discriminant is positive. If it says there's no real root, that means discriminant is negative. But in that question, we should find two equal roots, or it's same as one root. Discriminant should be 0. As you know, the formula of discriminant is b squared minus 4ac. And we know that here a equals to k, it's a variable, and b is 8, and c is also k. And then we can just substitute, because we know that b squared minus 4ac is, that formula is how we find a discriminant, and that should be 0. So 8 squared minus 4 times k times k, that should be 0. So 64 minus 4k squared equal to 0. 64 equals to 4k squared. And then just we can divide both sides by 4. 16 equal to k squared. So k is positive or negative 4. So C is the answer. We need the positive value of k. In 64, 2 rays drawn inside the right angle divided into 3 angles in the ratio. So we have a right angle 90 degree, and there are 2 rays inside. Let's say 2 rays inside. And the ratios are x, 3x, and 5x. So we know that the sum of that 3 angles should be 90 degree. So x plus 3x plus 5x should be 90. So 9x equals to 90. X should be 10. So this angle 10, that one 30, and that one 50. We should find the largest one. A is the answer. 50. Question 65. Find the sum of the lengths of all edges of a cube with one edge of length 6. So now we know that one of the edges 6, and we should find sum of all edges. As you know, edge is that length. So one of them is 6. And as you see, there are 1, 2, 3, 4 here, and 4 more. There are 4 more, so there are 12 edges. So for cube, there are 12 edges. If one of them is 6 centimeter, so all of them should be 12 times 6, 72 centimeter. B is the answer. #66. Which of the following number when multiplied by √294 results in a rational number? Here maybe you can check all that variance like √2, √3, √5, all of them. But I prefer just factorizing and trying to find a simple form of that radical. So 294 is divisible by 2. That will be 147. And it's divisible by 3, sum of the digits divisible by 3, then we can say it's divisible by 3. That will be 49, and we know that 49 is 7 squared. So root of 294 is 2, 3, 7, and 7. So we can take out that 7 √6. So we know that root of any number times root of the same number, square root. Square root of a times square root of a, that will be a. So here we have square root 6. So if we multiply it by square root of 6 again, that will be just 6. So 7 √6 times √6, that will be 7 times 6, which is 42. So we get the rational number. D is the answer. Okay, in 67, for the given quadratic equation, roots are x1, x2. Here we can say that it's x1 plus x2. So I want to show the sum of roots because from that equation, we can say that sum of the roots is, it's negative b over a. So that will be negative 12 divided by 1. That should be 12. And now we can say x1 plus 12 is 15. So x1 is 3. If x1 is 3, then we can substitute it. We know that 2 times x1 plus x2 is 15. And if x1 is 3, that will be 6 plus x2 equal to 15. So x2 equal to 9. So the question is find q. Here, maybe you can substitute 3 and then you can find the value of q. Or we know that q is the product of roots. So you can just multiply 3 and 9. That will be 27. So answer B. Again, if you want, we know that x1 is 3, then you can just substitute it. Again, q equals to 27. Next question, 68. A, B, C. In triangle ABC, C is the right angle, and D marked on the side AB. So there is D, we don't know where is that. And CD squared AD times BD. We use that formula when CD is height. So we know that formula, h squared equals to m times n. So we can say that CD should be height. And at the same time, we know that right angle and one more right angle. We learned that kind of formula. We said if it's a median, and that should be same as that length AD and BD. If it's a median, BD and AD, they should be same. And at the same time, CD will be same as that length AD and BD. So now we can say median is also true. Maybe it's a median. D is the answer. In 69, if the diagonals run from one vertex of a regular polygon to 8 triangles. So we know that sum of the interior angles for the triangle is 180. And if there are 8 times 180, we can find sum of interior angles. And then we can find the number of the sides by using the formula n minus 2 times 180. Or instead of wasting time, we can just say n minus 2 should be 8. So n equals to 10. So the number of sides of that polygon equals to 10. So to find one of the exterior angle, we can use that formula, 360 divided by n. As you know, for all polygons, sum of the exterior angles is 360, and then by just dividing it by the number of side, which is 10 here, we can find one of the exterior angle. D is the answer. Okay, 7. T. In 70, circumference of smaller circle is given, which is the length OB, is radius of that smaller circle. So we can say that 24 pi equals to 2 times pi times radius for the smaller circle. Radius equals to 12. Again, the length OB is the radius of smaller circle, and it's the radius. And we know the relation between that OA, we know their ratios, and AB. And BD is 5. So 4A and 2A, that is the length OB, which is the radius, equals to 12. So 6A equals to 12. A is 2. So that means that lengths are 8, 4, and 10. So AD is the radius of this greater circle, which should be 4 plus 10. It's 14. So the radius of greater circle is 14. So to find the circumference of the greater circle, again, we use the same formula, 2 pi and radius. That will be 28 pi, which is A. Uh, 71, again, one more inequality question. We can multiply both sides by 6, by positive 6. So x minus 5 will be less than 2. So just take this one to the other side. X should be less than 7. We need the greatest integer solution, which is 6. Less than 7, the greater one is 6. Find the remainder when the smaller 5-digit natural number. 5-digit natural number is smallest with distinct digits is divided by 4. Okay, so smallest different digits and 5-digit number. 5-digit number. The smallest one should start with 1. That should be, some of my students said that should be 1, 2, 3, 4, 5. So 12,345, but this is not the smaller one. That should be 0. So 1, 0, then 2, 3, 4. This 5-digit number is the smallest 5-digit number, which is a natural number with the distinct digits. Now we should divide it by 4. Maybe we can use that long division method, but instead of wasting time, you can just check 34, the last 2 digits. If it's divisible by 4, the remainder will be 0, or by dividing 4, we will see it's 8, remainder is 2, so we get the remainder is 2. So you don't have to divide that 5-digit number by 4. Just check last 2 digits. That's it. In 73, smallest root of the equation. Here, as we learned in the fractions, we have to make denominators same. We can make them same by multiplying first one x minus 1, other one by x minus 2. So that will be x plus 5 times x minus 1 over x minus 2 times x minus 1 minus x plus 3 times x minus 2 over x minus 1 times x minus 2. So as you see, the denominators are same now. So we can just say it's x squared minus 3x plus 2 on the denominator by multiplying them. We can find it. And then, same as denominator, we have to simplify the numerator. That will be x squared 5x, so negative 1x. So it's x squared plus 4x minus 5. Then minus, the other one should be x squared plus x minus 6. So let's open that parentheses. Because of that negative sign, I brought them in the parentheses, because that negative will change all the signs. That will be x squared plus 4x minus 5 minus x squared minus x plus 6 over x squared minus 3x plus 2 equals to 5. And then we can eliminate that x squares. So 4x minus x, it's 3x. Negative 5 and 6, it's plus 1. So x squared minus 3x plus 2 equals to 5. Now we can use cross multiplication. That will be 3x plus 1 equals to 5x squared minus 15x plus 10. Use cross multiplication. And then take all of them to one side. That will be 5x squared minus 18x, and then plus 9 equal to 0. So if you want, we can factorize it like 5x and x. That should be 3 and 3, negative. So negative 15x and negative 3x. That will be 5x minus 3 times x minus 3 equal to 0. And then x is 3 over 5, or 0.6. And here x equal to 3, zeros of the equation. So here we know that x cannot be 2 because of that denominator. And here x cannot be 1. So the roots are different than 2 and 1. And the smaller one should be 0.6. The answer is 0.6. But if you don't want to factorize it, you can use the discriminant formula. You can say negative 18 squared minus 4 times a times c, and then you will find the discriminant. And then you can use that root formula. By substituting, you will find the two roots again. Next question. Now find the smallest natural number that belongs to the set of positive values. Set of possible values of variable in the expression. As we said in the previous question, again we can say x cubed minus x, which is the denominator, cannot be 0. So here we can factorize it by taking x out of the parentheses, and then that will be obvious. So x squared minus 1 is x minus 1 times x plus 1. If that expression cannot be 0, then we can say x cannot be 0, x cannot be 1, x cannot be negative 1. So smallest natural number. So natural numbers are 1, 2, 3, 4, and others. So the smallest one is 2 here, because we said x cannot be 1, then the other one should be 2. Answer is 2. In 75 sides of the rectangle and perimeter, so widths and lengths, just 2 times lengths, 2 times widths and 2 times lengths, that will be 16. So answer is 16. In 76, root of 144 equals to 12. Again, 12 by 12, 144. That will be 12 again. 12 times 12, again, 144. And if we take it out of root, square root, that will be 12 again. So we get that it's root of 3 times 12, which is root of 36. And it's 6. So the answer is 6. In 77, the sum of 3 consecutive even numbers. So let's say the first one is 2a or 2n. The other one should be 2n plus 2. Other one 2n plus 4. So 3 consecutive numbers. So the sum of the 3 numbers, 3 consecutive even numbers, should be greater than 123. So 6n plus 6 greater than 123. So 6n should be greater than 117. So n is more than 117 divided by 6. So it's 19 times. So 3 over 6. So n can be 20. We need the largest number. That should be 2 times 20 plus 4. It's 44. So the numbers are 40, 42, 44. But we need the largest one. That's why the answer is 44. And 78. We need the right trapezoid. The base k minus 2 and 3k. Acute angle 5 times the smooth. So we have a right trapezoid. For that right trapezoid, as you know, that 2 angles are right angles, and it says the acute angle is 5 times smaller than obtuse angle. Let's say alpha, that should be 5 times alpha. And we know that 90, 90, 5 alpha and alpha, that should be 360. So alpha plus 5 alpha is 180. 6 alpha 180. So alpha is 30. So measure of this acute angle is 30. And obtuse angle should be 150. The question is, find the length of larger base. So we know that the smaller one is k minus 2 and the larger one is 3k, and shorter leg of the trapezoid, that one is 4 root 3. Here we should find the relation between that 4 root 3 and bases. So maybe we can draw that height, because we can see that 30, and we can say 30, 60, and 90 special triangle. We can say that if this side is 4 root 3, that should be 4 root 3, which is opposite side to the 30 degree. So opposite side to the 90 degree should be 8 root 3, and the opposite side to the 60, that should be 4 root 3 times root 3. which is 12. So we know that that length is 12. So this greater base minus smaller base is 12. Greater one minus smaller one equals to 12. So 2k plus 2 equals to 12. 2k equals to 10. Value of k equals to 5. So the smaller base should be 5 times 2. That should be 3. And the greater one, 3 times 5, that should be 15. That's it. The answer, 15. 79. Find the number of sides of the convex polygon whose number of diagonals is 42 more than the number of its sides. So the number of diagonal formula, it's n times n minus 3 divided by 2 should be 42 more than its side. So n plus 42. That's it. And then we can use the cross multiplication. By the way, we should find the number of sides. So by solving that equality, we will find the value of n, which is the number of sides. So let's use cross product. That will be n times n minus 3 equals to 2 times n plus 42. So n squared minus 3n equal to 2n plus 84. Let's take them to other side. That will be n squared minus 3n minus 2n minus 84 equals to 0. So the equation is n squared minus 5n minus 84 equal to 0. So the factors of 84 maybe 12 and 7. Negative 12, the sum is negative 5, that's it. So n minus 12 and n plus 7. These are the factors. So n equals to 12, n equals to negative 7. So the number side cannot be negative 7. So answer is 12. The number size is 12. In 80, so for the first inequality, we can see that that pi minus 3 and 3 minus pi, they have a relation. They are same. I mean, if we take this to the left side, that will be pi minus 3 times x minus 3 plus pi minus 3 less than 0. So as you see, pi minus 3 is same number. So we can take this out. X minus 3 plus 1 less than 0. As you know, pi is approximately 3.14, which means this part is positive. So we should just check x minus 3 plus 1 should be negative number. So x minus 2, the simple part, is less than 0. X is less than 2. And the other one, 2x squared here, 2xx, 5 and 1. Let's take negative 5 and negative 1 to find negative 11. So 2x minus 1, x minus 5. They are the factors. For the inequalities, it's better to find the zeros of the inequality, which are 1/2 and 5. And then by showing that regions, we will determine which part has the negative values. So in that part, maybe we can substitute 6. That will be positive number. In that part, maybe 2. That will be negative. Here, maybe 0. That will be negative 1, negative 5. That will be positive. So we need the negative part, this part. So 1/2 and 5. Now we need their intersection. Maybe you can show the number line. You can say the first one says less than 2, and the other one says 1/2 and 5, between 1/2 and 5. So it's obvious. The intersection part is from 1/2 to the 2. This is the answer. In that interval, those of that inequalities are true. In 81, find the area of triangle with the side ratio 4, 5, 6 and the perimeter 60. Let's say for x plus 5x plus 6x equals to 60. So 15x 60, x is 4. And the sides are 4 times 4, 16. The other side is 4 times 5, 20. The other side, 4 times 6, 24. Here we know that the 3 sides. And we can use the Heron formula to find the area. First, we should find the half of the perimeter, which is 16, 20, 24 half, or you can just divide 60 by 2. And then area equals to root of half of the perimeter times, as you know, the formula is root of half of perimeter minus all that sides, A, B, and C. So 30 minus 16, 30 minus 20, and 30 minus 24. So that will be root of 30 times 14 times 10 times 6. Here, it's better to write the factors, like 30 is 3 and 10. 14, it's 2 and 7. And keep that 10 because we have 10 here. And 6, it's 2 and 3 again. So we can take this 10 out. So we have 2 and 2. We can take 2 also. So 3, we can take it also. Only 7 in the root. So 10 by 2, 20 by 3, 60. 60 root 7 is the area of that triangle. That's it. Thank you for your attention.